I am going to begin with the topic of preferences and utility. Now, let's try and understand this a bit. What are preferences? What is utility? Two very, very separate concepts, but they have to be attached together and studied together. Preferences is going to just talk about ranking. It is going to talk about whether you prefer good A over good B, or you prefer a bundle X over bundle Y. But the moment you go about ranking commodities, what becomes important is to also give them certain numbers. And the moment you give numbers to your preferences, that takes the form of utility. So preferences is just ranking, just telling that, I prefer bundle A over bundle B. I prefer Kia over Nixon. I prefer mango over bananas. But utility is giving numbers to those and telling that, the utility that I get from mangoes is, let's say, 15. Whereas the utility that I get from bananas is, let's say, just 10. The moment you give these numbers, it becomes utility. So to understand these points further, we have to try and understand the axioms of rational choices. Now, for this entire course as a whole, the book that I'm going to follow would be Snyder and Nicholson. Whereas what you would have done as part of your graduation would be mostly Varian. I'm going to go through Varian also, but this would be covered as part of recorded videos that you would be getting on everyday basis. Whereas Snyder and Nicholson is something which we would be doing in the class, and the numericals of Snyder and Nicholson are of utmost importance. You will be asked questions from the numericals of Snyder and Nicholson. So that is what we would be practicing in the class. Varian workbook has to be done as an additional exercise, for which I would be posting the answers in the app. All right, let's jump back and understand what are the axioms of rational choices. The first axiom of rational choice is called completeness. What do we mean by completeness? By completeness, I mean that a consumer should be able to specify or to tell exactly one of these three things. Consumer should be able to tell whether consumer prefers A over B, or B over A, or whether the consumer prefers A and B equally. Consumer should not be indecisive. What do I mean by indecisive? Which means that consumer should not be saying that I do not know. Consumer should always be able to tell that, this is what I believe in. I believe that I prefer A over B, or I believe that I prefer B over A. The indecisive attitude of consumer is not something that we take into consideration. Sorry, just give me a second. So, the consumer should be able to tell that he prefers A over B or B over A, or the two equally. Now, this actually rules out the assumption of, this thing. So, for example, if the consumer says that, if there are two bundles, A and B, and the consumer says that, I prefer A over B, and at the same time, I prefer B over A, this kind of attitude, this is ruled out. This is not something which the consumer can do. as part of completeness. The consumer cannot say that I prefer A over B and at the same time I prefer B over A. The consumer has to decide, has to give his decision exactly what he feels. The second property or the second axiom of rational choices is called transitivity. And what is transitivity? Transitivity says that if A is preferred over B and B is preferred over C, then A is preferred over C. The general maths. Similarly, transitivity says that if you're indifferent between A and B and you're indifferent between B and C, then you would be indifferent between A and C also. Let's see how this transitivity goes ahead and transforms itself into utility. So let's just try and write that down. See, supposedly I give you a bundle A and this bundle has 10 units of good 1 or good X and 2 units of good Y. I give you another bundle B and this bundle B has 5 units of good X and 1 unit of good Y. Then, because bundle A has more of good X and it also has more of good Y. Do you see this? This is 5 versus 10. This is 1 versus 2. So, A has more of both the goods, X and Y. Therefore, A should be preferred over B. The sign is this. Now, if A is preferred over B, then in terms of utility, I can say that the utility of A is greater than the utility of B. This sign now changes to a greater than sign. This is the sign of preferences. Do you see? This is a little peak and this is the usual greater than sign. So when one thing is preferred over the other, when good A, bundle A is preferred over bundle B, then the utility of bundle A is going to be greater than the utility of bundle B. Similarly, if I say that A and B, the consumer is indifferent, both the bundles provide the consumer the same level of utility, then in that case, utility from A will be equal to utility from B. So, this is for indifference or preferences, and this is for utility. It is very important for you to distinguish between preference and utility. Preferences have signs like this. Something is preferred over the other. You are indifferent between two bundles. You are weakly preferring something over the other. Whereas utility has these signs. One has more utility than the other. The two have exactly same utility or greater than or equal to utility. So when we talk about transitivity, in transitivity, we say that if A is preferred over B, B is preferred over C, then A is preferred over C. If A is weakly preferred over B, B is weakly preferred over C, then A is weakly preferred over C. Very, very important, because I'm going to use this in the DSC entrance exam questions. And how am I going to use this? I'm going to ask you questions like this, and we would be proving this in the advanced video sections. But supposedly, I ask you a question which says, if A is strongly preferred over B, and B is indifferent to C, or indifferent between B and C, then prove to me that A is strongly preferred over C. Now, just by looking at it, it might seem easier, but we may have to do this in terms of utilities. So these are the kind of questions that I would be asking you as part of transitivity. So therefore, these relationships hold importance. If A and B, you're indifferent, B if you're indifferent between A and B and C, then you are indifferent between A and C. The next property or the next axiom of rational choices is continuity. This axiom is especially important because we are dealing in a mathematical world. And because we are dealing in a mathematical world, we cannot afford discontinuity. If my function is discontinuous, for example, if my utility function looks something like this. Now, I know that one property of indifference curve is that all points on indifference curve give me the same level of utility. Right? So this would mean that, point A and point B would give you the same level of utility because they're on the same indifference curve. But then, if this indifference curve is discontinuous, the question that arises is, what about point C? Will you be indifferent between A and C also? We don't know. And if we don't know, then we are rejecting our completeness theory. Because here I am saying I do not know. The consumer is indecisive. So I don't want to have that assumption. I don't want to have the property of indecisiveness. I don't want to, therefore, have the property of discontinuity. So I want to be in a world where my indifference curve is continuous. So if A is preferred to B, then continuity would mean this. Supposedly, I take a function which is continuous. This is my indifference curve. Now I take a point A and I take a point very, very close to it, very close, epsilon close to it. Supposedly, I take a point like this, A dash. And now I take a point like this, B. And I tell you that A is preferred over B. Then continuity suggests that any point which is very close to A, epsilon close to A, supposedly a point like A dash, should also be preferred over B. That's the property of continuity. So if supposedly, let's take another example in terms of the bundles. Supposedly, I give you a bundle A. Bundle A is 10, 1. I give you a bundle B. Bundle B is 2, 1. And I tell you that A is preferred over B. Makes sense, right? Monotonicity. If you have more of the good, you should prefer that. So A has more of good 1. I would be preferring A over B. Now, continuity suggests that if I add very, very less amount, if I bring in a point which is super close to A, let's say 10 plus epsilon, 1, where my epsilon is very, very small. Let's say my epsilon takes the value 0.00000001. Very, very small. It's very close to A. Then, because this because this is very, very close to A, this will also be preferred over B. And this is from the property of continuity. So I'll go back to the property of continuity and let's read this out. If A is preferred to B, then situations suitably close to A, something which is very, very close to A, must also be preferred to B. This is the property of continuity. Now, if these three properties hold true, completeness, transitivity, and continuity, if I hold these three assumptions, then it is possible to show that people can rank in the order of all possible situations. If you have continuity, completeness, transitivity, and I understand by now that you know what these three things are. If you understand these three things well, what is completeness, what is transitivity, what is continuity, then you can say that from these three properties, given any two bundles, consumer will be able to rank those bundles. And because consumer will be able to rank those bundles, consumer will be able to assign number to those bundles. And that number is nothing but utility. So let's see how. Supposedly, I say that I give you two bundles, A and B. Bundle A is 10,4 and bundle B is 5,12. Now, my first property, completeness, tells me that either consumer will be able to tell me that he prefers A over B, or he prefers B over A, or he is indifferent between A and B. Consumer should be able to make a choice. That's completeness for me. Secondly, the second property is transitivity. You know, if consumer tells me that he prefers A over B, this is the final decision that the consumer has taken, then in that case, any other bundle over which B is preferred, supposedly B is preferred over a bundle like C, automatically assumes that A will be preferred over C. And third thing, continuity. This just assumes that if A is preferred over B, then any bundle too close to A should also be preferred over B. My indifference curves are continuous in nature. So because I assume these three things, these are the three assumptions that I'm making at any point of time. Therefore, because of these assumptions, I can go ahead and I can say that consumer will be able to give you ranking and give you or assign utility to different bundles. This holds the base of any consumer theory. There are too many questions that are going to come from these three axioms. So these three axioms are very important. Any doubt that we have till now? All right, so I'll move forward then. Now, you know, we also say that utility is an ordinal concept. And by ordinality, what I mean is that I can give you ranking of the bundles, but I would not be able to give you the numbers itself. Now, this thing might seem a bit confusing because we just gave some numbers to utility, but what do I mean here is the following. For example, let's say that I have a bundle which talks about visiting a restaurant. Consumer A visits a restaurant and he visits, let's say, a Chinese restaurant, and then he visits a North Indian restaurant. And he tells me that when he visited this Chinese food restaurant, he got a utility of 100. Whereas when he visited this North Indian restaurant, he got a utility of 20. Well, fine enough. This tells me that he prefers Chinese food over North Indian food. Or at least from the two restaurants that he visited, his experience was that the utility from the Chinese restaurant was much more than the utility from the North Indian restaurant. Good. Now, consumer B also visits these two restaurants. He also loves Chinese over the North Indian food, but he tells me that when he visited the Chinese restaurant, he got a utility of 4. And when he visited the North Indian restaurant, he got a utility of 3. Now, the only conclusion that I can draw from this is that the utility that consumer B got from the Chinese restaurant is greater than the utility he got from the North Indian restaurant. That is it. I cannot go ahead and say that consumer A got more utility than consumer B when he visited the Chinese restaurant. This would be absolutely wrong statement to make. You cannot do that. Maybe the scale that consumer A was using was way different from the scale that consumer B was using. Maybe his utility scale only varied from 0 to 5 and his utility scale varied from 0 to 100. So I do not know that. All that I can use utility for, these numbers for, is for the purpose of ranking. All that I can say is, yes, both the consumers loved Chinese over North Indian food, and that is it. I cannot go ahead and say that consumer A loved Chinese more than consumer B because I do not know the scales that they were using. When I go to when I eat a McDonald's burger, I might be getting more utility than you are getting. But the number that I state may be a lower number. So utility is only limited to the concept of ranking. You're only saying you prefer A over B or B over A, and that is it. It is not going, this is the sole purpose of utility. It is not going ahead and it's not comparing. You cannot say that, you know what, this person received 25 times more utility than this person. It is not going to make sense. So that is important, and this is actually when we talk about this thing, this is the concept of ordinality. This has to be clubbed with one more important thing, which is that, for example, I live in Delhi. For me, my the peer group that I have, they usually take me to places which are having loud music and to places which have late nights. And supposedly someone lives in a smaller town, and for them, according to their friends, he or she goes and visits a place which is much silent and which is a beautiful open area where they just go and have an afternoon brunch. So the point that I'm coming to is that utility whenever you come up and you tell me that you get this much utility from, you know, this late night cafe, and the other person tells me that he gets this much utility from, you know, this place, that utility is also getting affected by a lot of other things. And what are those other things? Those things are your psychological attitude, peer group pressure, personal experiences. Maybe my personal experience has been such that if a place is a quiet place, I can read down my book easily, and I love reading books. So all those things are also going to impact your utility. Because I want to compare bundles, economists usually just devote attention to quantifiable options, and they hold all these other things constant. And this is known as, and you would have heard this word a lot, ceteris paribus. What is ceteris paribus? Ceteris paribus is when you hold a lot of things constant. You're holding, you know, attitude of people, peer group pressure, personal experiences, the place they belong to, all of those things are held constant, and you are just interested in the quantifiable option of utility. That is what is ceteris paribus assumption. All right. So now we have gone through all the axioms of the utility of the rational choice. We now understand that any consumer can rank bundles. Because the consumer can rank bundles, the consumer can also go ahead and give you the utility, that I get this much utility from this bundle. Because the consumer can do that, we can write this mathematically as a utility function. What is a utility function? Let's see that. A utility function basically gives you the utility that you get from various commodities. So I am consuming x1 units of good 1, x2 units of good 2, x3 units of good 3, and so on till xn units of good n. And by consuming all of these things, I'm getting certain utility. So for example, you may be consuming 2 units or 2 hours of Netflix. You may be consuming 4 hours of reading. You may be consuming 5 McDonald's burger. You may be consuming 2 fruits. You may be consuming 100 rupees per day of your pocket money, etc. You're consuming hundreds of things in different units. All of that taken together is going to give you a number, and that is your utility. Now, a lot of times it is very difficult to work in this n commodity space. What do I mean by n commodity space? When I have n commodities, my axis is going to be n dimensional, and it is going to be very difficult for me to graphically represent this thing. Therefore, what I do is I narrow down all of this thing into a 2 commodity case. So I just say that I consume 2 commodities, good 1 and good 2, or good X and good Y, and I get utility as U of X comma Y. That is it. This is just a simplified version of these n commodity consumption. So, you know, before I go further to the concept of economic goods, I would like to focus a bit more on this utility, and I would like to highlight that as we are going to go ahead and we are going to do numericals on intertemporal choice. We are going to do numericals on labor leisure. You would see that this x and y is going to take various other forms. For example, I would take my utility function I would give my utility function a form of how many units of labor and leisure I consume. How many units of wealth I have. I can give my utility an intertemporal form. I can say how many units I consume in period 1 and how many units I consume in period 2. This becomes a 2-period case. Right? So need not be the case that my utility function just takes the form of 2 commodities. It can take the form of labor leisure. It can, by the way, labor and leisure would be, 2 things of the same, 2 things of the same coin. If you give more hours to labor, you give less hours to leisure. So we will see how that works with the wage theory. Or my utility function can be an intertemporal utility function. It can be a wealth utility function. If we go ahead and we see, I can also use some of these aspects to my macroeconomic theory. Again, as we progress, we will have a look at that. Okay, so now I want to go ahead and I want to, talk about economic goods. There is this basic video that you have to go through. This is a video from Varian. And this video is going to explain to you this. So, it would be given to you. And this video explains to you all the cases of the goods. So you can have a look at that video. It will help you to complement what we are doing right now. I have explained there what is good, what is bad good, what is the case of bad goods, etc. So all those cases I've taken and explained. So today, what I'm going to do and what we are going to progress throughout will be the case where I'm just going to assume that both my commodities are good goods. So, just understand all those cases. We take good here, bad here, bad here. If the 2 goods are good goods, then my indifference curve is this. If one is good, the other is bad, my indifference curve looks like this. If one is bad, the other is good, my indifference curve looks like this. Otherwise, my indifference curve looks like this. Something which is explained as part of the basic videos. All right. So let me come back to economic goods then. What are economic goods? Economic goods are goods which give me good utility, positive utility. For example, for me, Netflix is an economic good. For me, my car is an economic good. For me, burgers are economic good. For me, books are economic good. What is a bad good for me? For me, pollution is a bad good. COVID-19 is a bad good. Diseases are bad good. So for now, I'm going to go ahead and assume that both the goods are good goods, which means you prefer more of the good over less of good. So I take a point and you will see how I'm going to use this to kind of develop the indifference curve. So I take a point x star, y star, and now I go ahead and I say that any point which is to the right, upper right of x star, y star, this region, this becomes my preferred region. And we'll see why. Let's try and prove this also. But any point which is here in this region, all these points are preferred to x star, y star. And all these points that lie in this region are not preferred over x star, y star. Or alternatively, you can say that x star, y star, this point is preferred over all these points. The question is why? Let's see that. So I've taken this point X star, Y star. I'm going to go one by one and I'm going to talk about points like this. So I'm going to take a point this. Now, let's see what has happened from this point to this point. Let's name this point as A. Let's name this point as B. Now, I'm going to give you a theory before we go ahead, and that's the property of monotonicity. See, monotonicity means more is preferred. But you have to be clear when more is preferred. So more is preferred in the following way. If you have more of one good, I would not say more of one good, I will say more of at least one good, and same amount of the other good, then you will prefer that bundle over the other. Let's see what this means. Very important. So, supposedly I take the case of A being 10, 5. And I take the case of B being 12, 5. B has more of one good. It has 12 units of good 1. And B has same amount of the other good. Both of them have 5 units of good 2. Then, if good 1 and good 2 are economic goods, which means you prefer more of those goods, B should be preferred over A. This is the concept of monotonicity. Let's take other case now. Supposedly I tell you that there is another bundle C. C has 20 units of good 1 and C has 10 units of good 2. Then it's very clear choice. C has more units of both good 1 and good 2. So, both of them are more. Definitely C is preferred over A. But let's take the next case. Suppose I tell you that there is D. And D is, let's say, 12, 3. Then I cannot compare A and D. Why? Because when I go from A to D, no doubt good 1 is increasing, but good 2 is also decreasing. So I cannot compare that. This bundle cannot be compared, even through monotonicity. Monotonicity can be used only when you increase the consumption of one good, whereas other remains the same, or even the other increases. Now let's go back and see this diagram. In this diagram, if I compare point A to point B, you will see both of them have same amount of good Y, right? This also has this much good Y and this also has this much good Y. So point A and B have same amount of good Y, but point B has more of good X than point A. So it is a clear choice. B should be preferred over A. Now let's take a point like C. Point A and C have same amount of good X, but C has more of good Y. Again, from monotonicity, when you have same amount of one good but more of the other good, you're going to prefer that bundle. So C is preferred over A. I can do it for any bundle, right? This bundle will also be preferred over A. This bundle will also be preferred over A. This bundle, this bundle, this bundle, all bundles close enough to A, but having more of A will be preferred, right? If that is the case, take a bundle like D. D is a clear choice. D has more of X and more of Y. D has to be preferred over A. So D is also preferred over A. I can do it for E also. I can do it for F also, and so on. So therefore, this entire region consists of bundles that are preferred over A. Now, as an assignment, try and prove this, why the bundles that are here will be worse off, because they will have at least one of the less good as compared to A. So just try and prove this. Now, the point that arises is what happens to bundles that are in this region and bundles that are in this region. Here, the consumer will be indecisive. Because let's compare A point let's say this is point A, and I'm comparing this point A with point E. Then E has more of good X, but E has less of good Y. So E cannot be compared to A. A very same case than this. One good is increasing, the other is decreasing. So the diagram that we have is this. Anything that falls in this region is definitely preferred to this bundle. Anything that falls in this region, you are going to get worse off. For these regions, you cannot say anything, because one is increasing and the other is decreasing. So based on the concept of that, I'm going to take it further and I'm going to introduce to you the indifference curve. What is an indifference curve? An indifference curve consists of all the points that give the consumer the same level of utility. So this point right here, this point right here, any other point on the indifference curve, all these points are giving the consumer the same level of utility. Now, supposedly, I write my indifference function as this. Then, on any indifference curve, my utility is held constant at one level. So, for example, let's take an example and do it. My utility function looks like this. X1 to the power half, X2 to the power half. If I have to compare, if I have to say what are the points that lie on this indifference curve, I can hold my utility at some level. I can say, let's say that my utility, by the way, I can rewrite this as X1 into X2 to the power half, right? Or I can also write this as X1, X2 root. Okay. Now, supposedly, I want to talk about all the points that lie on the indifference curve. Then, all the points that lie on the indifference curve, the utility will be the same. Let's say I want to draw an indifference curve for utility 10. So I am going to rewrite this as 10 is equal to root of X1, X2. Let's take square on both sides. I'm going to get 100 is equal to x1 into x2. Or I'm going to get x2 is equal to 100 by x1. This is going to be your equation of your indifference curve. You put different values of x1, you will get different values of x2. So when your x1 will be 1, your x2 will be 100 by 1, which will be 100. When your x1 will be 25, your x2 will be 100 by 25, which will be 4. When your x1 will be 100, your x2 will be 1. This point, and this point. All these 3 points are going to give you the same level of utility. Because, and what's the level of utility that it will give you? 10. Because you're fetching them from the same equation. So they will have the same level of utility. I'm going to continue this example once I tell you what MRS is. So let's go ahead and talk about marginal rate of substitution. What is marginal rate of substitution? Marginal rate of substitution is the negative of the slope of the indifference curve. Question to you. How do you find the slope of any curve at any point? What's the basic maths to calculate the slope of anything? The slope of the function is given by perpendicular by base. So in our case, the slope will be, so supposedly, I have to find the slope here for this part. It will be perpendicular by base, right? So it will be how much quantity changes in y by how much quantity changes in x. That is going to be the slope of my indifference curve. And if I take this further, this is going to be how much y has to be given up for an additional unit of x. Makes sense, right? I'm going from a point like A to a point like B. I'm giving up my y, consumption of y, to consume an additional unit of x while being on the same indifference curve, while holding the utility constant. And that is exactly what it is telling me. That's what the meaning of the slope here is. So the slope tells you how much units of good y have to be given up to consume an additional unit of good x such that you hold the utility constant. So whenever you say MRS, I will shortly give you mathematical derivation of this also. But whenever you write MRS, MRS is dy by dx holding utility constant at some level with a negative sign, because MRS is always negative of the slope. Now, how to find the slope? So let's say that my utility function is u as u of xy. What I'm going to do is I'm going to total differentiate the function. Let's total differentiate this function. What will I get? I will get du is equal to del u by del x dx plus del u by del y dy. This can be further solved I know that my du is 0. Why? Because I am on the same indifference curve. And as long as I am on the same indifference curve, the utility remains the same. There is no change in utility. So change in utility becomes 0. So I can say 0 is equal to del u by del x dx plus del u by del y dy. Del u by del x is nothing but marginal utility of x into dx plus del u by del y is nothing but marginal utility of y. What is marginal utility? How utility changes when the consumption of good x changes. So this is nothing but marginal utility of good x. Again, I'm emphasizing this would be covered as part of the basic videos there in the recording section. Go through those ones. So this is nothing but how utility changes when good x changes. Marginal utility of good x into dx plus marginal utility of y into dy, and this is equal to 0. So if I solve this, I'm going to get dy by dx is equal to minus of mux by muy. So the slope of the indifference curve at any point of time is minus mux by muy. And since MRS is negative of the slope, MRS becomes mux by muy. This is the definition of MRS. Okay. I'll give you a 5-minute break right here before we continue. And I'm going to take all the doubts that you have till now. Now, what we want to also do is we want to try and understand what happens to MRS. Now, if I look at the slope of the indifference curve a little closely, what you would notice is that if I go from a point like A to a point like B, I can find perpendicular by base right here. And let's say I go from a point like C to a point like D, and I can find perpendicular by base right here, right? What I will observe is that here the slope is steeper, and here the slope is flatter. What does a steeper slope depict? A steeper slope depicts that you are ready to give more of good to consume an additional unit of the other good. And what does a flatter slope depict? That you will give less of good for an additional unit of the other good. Let's see what this means. This means that if I look at a point A, then I just had 1 unit of good x, and I had too many units of good y, let's say 100 units of good y. Because I had too many units of good y and I had too less of good x, I was willing to give up too much of good y, but I wanted to consume some more of good x. So my willingness to give up good y for an additional unit of good x was high because I had huge amount of good y. Now let's look from point C to point D. At point C, I have 2 less of good y. Maybe I just have 4 units of good y left. And I have too much of good x. Maybe I have, 75 units of good x. Because I already have too much of good x and I have 2 less of good y at point C, my willingness to give away good y for good x will be too low. I would be willing to give lesser of good y for an additional unit of good x. Well, your willingness to give good Y for good X is nothing but MRSXY, marginal rate of substitution. That tells you how much you're willing to give up one unit of good, how much you're willing to give up good Y for an additional unit of good X, because this is nothing but minus dy by dx. For 1 unit of good X, how much Y you're willing to give. So the concept here is that MRS is diminishing. And by diminishing, I mean that as you move down the indifference curve, your willingness to give good Y keeps on decreasing. And why would that happen? That happens because you have lesser and lesser of good Y. So you don't want to sacrifice a lot of good Y for good X. And therefore, your willingness would decrease. This can be represented like this. So at this point, your indifference curve is steeper slope. This is the slope. At this point, your indifference curve has a flatter slope. Slope decreases or diminishes. Or in other words, MRS diminishes. Now, a lot of times in the questions, you would be asked to give indifference map. What is indifference map? Indifference map is when you draw too many indifference curves together. So all the indifference curves together give you an indifference map. This is again going to be useful as we progress ahead, because what I'm going to do very shortly in the coming lectures is that I am going to ask you about monotonic transformation. And I'm going to ask you about what happens when the slopes are similar at different points and you pass lines through them. So for that, you should be very clear with the concept of indifference curves. So indifference curve map is when too many indifference curves are drawn together. And the only concept you have to keep in mind for now is that as you go to a higher and higher indifference curve, the utility keeps on increasing. So utility at this indifference curve is higher than this indifference curve, which is higher than this indifference curve. Now, the concept of transitivity and monotonicity can help you derive an important theory, which is that two indifference curves cannot intersect. Let's try and see why that is true. So I'm going to take a point like A and C. A and C lie on the same indifference curve U1. And because they lie on the same indifference curve, an individual should be indifferent between A and C. If the individual is indifferent between A and C, then the utility from A should be equal to the utility from C. Similarly, B and C lie on the same indifference curve U2, which means the consumer should be indifferent between B and C. This implies that the utility from B should be the same as the utility from C. But my monotonicity tells me that B has more of both the goods than A. So from the concept of monotonicity, I know that B is preferred over A. And this means that utility from B is more than utility from A. If I combine equation 1 and equation 2, I will get utility from A is equal to C, utility from B is also equal to C. From transitivity, utility of A should be equal to utility from C. Sorry, should be equal to utility from B. Now, transitivity tells me that A and B have same utility. Monotonicity tells me that A and B have different utilities. These two are contradictory to each other. And because they are contradictory to each other, I can conclude that this is not the way that indifference curves should be drawn. Therefore, these two indifference curves cannot intersect. And that is exactly we have tried and proven. The next concept that you have to understand is the concept of convexity of indifference curves. Now, this is something that you would have done in maths also. So, we will do this in detail when we are going through the mathematical course. There are two things. One is convex curves and one is concave. Now, in simple terms, in terms of derivatives, when I talk about concavity, I am saying that the double differentiation of the function is negative. And when I talk about convexity, I am saying that the double differentiation is positive. That's convexity and concavity for us. For indifference curve also, we can try and prove this. Now, what would this mean? This would mean that the moment I know that the slope of the curve is MRS XY, all that I have to do is I have to see what happens when I go ahead and I double differentiate this. I differentiate this again and it comes down to be a positive value. That would be convexity for me. But there is other way also to check whether something is convex or not. And that is the concept of preferring averages over means. What do I mean by that? By that, I mean that if I take any extreme value, then that extreme value will be less preferred over the mean or average value. Let's try and see what that means in detail. Supposedly, I take a point which is 1,25. Sorry. And I take other point which is this. Then I am saying that, and I know that, if this is point A and point B, because point A and point B lie on the same indifference curve, utility from point A will be same as utility from point B. Now, what I want to further go ahead and do is I want to see what happens with the average. So what I'm going to do is I'm going to take an average bundle, which is going to be 1 plus 25 by 2, which is going to be a bundle 13, comma 13. And I am going to use my simple concept of what I have done till now, which is this. So here, what we have done is, we are saying if I take any point and I make this triangle all these points are preferred over this point, right? I'm just using this concept. And I'm going to use this concept here. So for my 13, bundle that I have, I'll take a point here, point A. Obviously, point A, point B, point C, all of them have same utility. They're on the same indifference curve. And for this bundle, I will draw this. And I know now that all these points right here fetch me higher utility. And because they fetch me higher utility, I know for sure that a point like this has higher utility than this. So if I name this point as D, where bundle D is 13, 13, then I know that the utility at D is greater than the utility at A. We have already proved this right now. But I know that utility at A, B, C is the same. They're on the same indifference curve. So this means that utility from D will be greater than utility from A or B or C. So D will be preferred over its extreme values. The average points that I've taken, that is preferred over these extreme values. This is like joining these 2 points. So, you know, any point which is the average can actually be passed through a higher indifference curve. And hence this point is preferred over the extreme points. That is the concept of convexity. Convexity suggests that when you, and this is going to be very important when I'm going to solve DSC questions, because I'm directly going to use this concept of, I'm just going to directly write down an equation like this, that utility from x1 plus x2 by 2, comma y1 plus y2 by 2 is greater than utility from x1 comma x2, comma y1, sorry, or is greater than utility from x2 comma y2. So there, you know, you have to just think that this came out of our assumption of convexity. So convexity is this. Now, in terms of economists, we say that something which is a well-balanced bundle, that is preferred over something which is heavily weighed towards one commodity. So if to any individual, you're going to go ahead and tell the individual that, you know, I give you 1 unit of chocolate and 100 units of book, and I give you 100 units of chocolate but just 1 book, and other one is a well-balanced bundle. You tell him that, you know what, I'm going to go ahead and give you, let's say, 51 or 50 units of chocolate and 50 units of books. Then the consumer will prefer this well-balanced bundle. That's convexity. Now, so, you know, what we have done is, I'm going to go ahead and solve this question for you now. So I have a utility function that is given to me. The utility function that is given to me is root of xy. The utility that is given to me is 10. I just did this couple of minutes back. If I take square on both sides and I solve this, I'm going to go ahead and get, taking square on both sides is going to give me 100 is equal to xy. And I can solve for y and get 100 by x. If I solve this further, I have to find out what is MRS. MRS was negative of the slope. To find the slope, I'm going to differentiate the function. So if y is 100 by x, dy by dx is going to be minus 100 by x square, because the differentiation of 1 by x is minus 1 by x square. So you differentiate this function, and post differentiating the function, you're going to put a negative sign with it because you're finding MRS. MRS is negative of slope, and you get your MRS as 100 by x square. Once you get your MRS, what you're going to do is you're going to say that I'm going to take different values of it. So I'm going to go ahead and say, let's say that x is 1. So if I take x to be, let's say 1, I'm going to get MRS as 100. Let's say I take x to be 5, then 5 square will be 25. MRS will be 4. Let's say I take x to be 20, then MRS will be 100 by 20 square, which will be 100 by 400, which will be 1 by 4, which will be 0.25. I'll pause here for a second. Just think what we are trying to show. When x was 5 units, I had lesser units of x. I wanted to give up more to get an additional unit of x. The moment x became 20, I had enough of x. And because I had enough of x, I wanted to give less units of x I wanted to give less units of y for an additional unit of x. To be specific, I just wanted to give up 0.25 units of y for an additional unit of x. This is exactly the concept of diminishing MRS. So I can say that what was my x? My x was, I think so, hamburgers, soft drinks. So I wanted to give more of hamburgers. I wanted to give 4 units of hamburgers for an additional unit of soft drink. And later on, I just wanted to give a quarter of hamburger for 1 unit of soft drink. Now, I've already proved this for you. How do we find this mathematically? I've derived the MRS for you. MRS is dux by duy. This is nothing but mux by muy. Marginal utilities of x and y. Now, once we have done this, I want to also go ahead and focus on something which is known as the law of diminishing marginal utility. Please note that I'm writing here the law of diminishing marginal utility and not diminishing MRS. I want to first focus on this. So, I've covered this as part of the basic videos also. But what is law of diminishing marginal utility? The law of diminishing marginal utility states that as you keep on consuming the commodity, the utility, additional utility that you will get will keep on decreasing. So, as, for example, let's take the example of your favorite food. Let's say I'm taking the example of Pani Puri. You take in the first bite of it, you get a very high utility. You take in the second bite of it, your utility decreases. You take in a third bite, you're still loving it, but not as much as that first Pani Puri that you had. You take in the fourth bite and you've achieved your saturation. You don't want to consume it anymore. You take in another bite and you think that, if you take any more, you may vomit. That is diminishing marginal utility for you. As you keep on consuming more and more of the Pani Puri, the additional utility that you keep on getting would be lower and lower. And after a point, you may want to also vomit. You may not want to have any more of it. So, the concept of diminishing marginal utility says that marginal utility of x or marginal utility of good y, whichever good you want to talk about, diminishes as x increases or as y increases. Now, you may ask me, why is this important? Because let's say that I'm talking about my let's say that I'm talking about my indifference curve. And I am at a point like A, and I want to go to a point like B. At A, I had certain amount of good x, let's say x1. I had certain amount of good y, let's say y1. At B, I had certain amount of good x, let's say x2, and certain amount of good y, let's say y2. Now, when you move from point A to point B, what happens? Good x increases. Because good x increases, by the concept of diminishing marginal utility, MUX should decrease. When you go from point A to point B, good y is decreasing, isn't it? You're consuming less of good y. If good y is decreasing, the marginal utility of good y is increasing. Now, what was MRS? MRS was MUX by MUY. When I go from point A to point B, the numerator is decreasing because MUX is decreasing. The denominator is increasing because MUY is increasing. If the numerator decreases, denominator increases, the entire term decreases. So MRS decreases. That is the mathematical proof of why MRS is decreasing. We can go into derivatives also and do that, but this is just a way of telling that as you go from point A to point B, MUX decreases due to law of diminishing marginal utility, MUY increases, so overall MRS XY decreases. Now, once you have done that, this is important for you to understand, something that I've just explained you, that diminishing MRS, it actually is, more of diminishing MUs, because marginal utilities follow the concept of diminishing marginal utility. Therefore, we are able to prove that MRS in itself is also diminishing. Now, let's say that my utility function is root of xy again. What I'm going to do is I'm going to go ahead and I'm going to take log of the utility function on both sides. So if my utility function is root xy and I take log of this function, I'm going to use certain concepts here. Please brush up your log concepts. So log mn is n log m. Log mn is log m plus log n. So if I take log on both sides, log u will be log xy to the power half. This will be half log xy. This will be half log x plus log y. Okay, this will be half of log x plus half of log y. Okay. So this is what I've written, 0.5 ln x plus 0.5 ln y. Now, if I have done this, then, if I say my final utility function is half log x plus half log y, then my MRS will be, I'll explain something very important from here. Let's just solve this for a second once. So my MRS will be how utility changes when x changes. So I differentiate the function with respect to x. So the differentiation of ln x is 1 by x. So I will get half into 1 by x. The differentiation with respect to y will be half into 1 by y. So this will be 0.5 by x, 0.5 by y. And finally, this will give you y by x. This is your MRS. I want to pause here for a second and I want to talk about another very, very important thing that is asked in exam, which is monotonic transformation of function. A lot of times, you're given two functions, two utility functions. Supposedly, I give you a function this, and I give you another function this. And I ask you a question, do these two functions give you the same utility? Now, just by looking at the two functions, it may be a little difficult for you to identify if these two functions give you the same utility or not. Then, although I just proved this, I started with this function. If you notice, I started with this function. I just did a log transformation of the function and I got the other function. So ideally, the two functions are the same. They're doing the same thing to me. But if that becomes difficult for you to understand, what you can do is you can simply find MRS of the two functions. If the MRS comes out to be the same, then actually the two functions are just, have the same base. They're just transformation of one another. So what I'm going to do right here is I'm going to try and find, so I have just proved that MRS of this one came out to be y by x. Let's find out the MRS of this. So the MRS of this function will be differentiation of function with respect to x upon differentiation of function with respect to y. This is going to be, so I can write this as xy to the power half. So when you differentiate it with respect to x, half comes down, xy to the power of minus half. You subtract 1 from it, into differentiation of xy will be y. Right? Upon, you differentiate it with respect to y. So you get half xy to the power minus half into differentiation of xy with respect to y will be x. This all gets cancelled out and you get the same thing as y by x. So ideally, this function right here and this function right here are the same because the MRS in the background is the same. What you should try is the following. Take the utility function as this. And tell me if it's a monotonic transformation of this utility function. Whether the two utility functions are actually the same in the background or not. Do they represent the same preferences or not? Just solve that once and then we will discuss it. Okay. So now I'm going back to where I just landed up. Because these two functions are the same that I just used, the MRS is coming out to be y by x. What I'm going to do is, what happens if my utility function is actually x plus xy plus y? Let's try and see what my MRS will be here. There is no reason why I would want to transform this function. This is a simple additive function. I don't have to take log, or I don't have to do anything. So I'm directly going to go ahead and find the MRS. Differentiate this function with respect to x. When you differentiate this function with respect to x, differentiation of x will be 1. Differentiation of xy will be y. Differentiation of y will be 0 because I'm differentiating with respect to x. Upon differentiate this function with respect to y. So when you differentiate it with respect to y, this is gone. This will give you x. You're taking x as a constant because you're differentiating with respect to y. You know, these are partial differentiations, plus differentiation of y becomes 1. So you get the MRS as 1 by y by 1 by x. Now, suppose the utility function is this, and I ask you, give me the MRS. Your wish, whether you want, you can go ahead and transform this function, take log so that this becomes easier, or you have a better way of transforming this function. How? You can write this as x square y square to the power half. This just becomes x square to the power half into y square to the power half. This is just xy. Just find out the MRS. So, you know, if you find out the MRS of this, the MRS will be differentiate this with respect to x, that will be y. Differentiate with respect to y, that will be x. So the answer will be y by x. If you want, you can also do a transformation of this. Transformation, one transformation is directly doing this. The other transformation can be going ahead and doing a log transformation. When you do a log transformation, you can go ahead and say u is equal to root of x square y square. Log of u is equal to log of root of x square y square. If I solve this, this will be log of x square y square to the power half. I will bring down half here and I will say log of x square y square. That would be half of log of x square plus log of y square. That would be half of 2 log x plus half of 2 log y, and that would be log of x plus log of y. Again, there would be questions which would say whether this function and this function, are these functions the same or not. There may be a case that may say whether this function, and you know, they may want to take exponential on both the sides. So if my utility function is root of x square y square, then taking exponential on both the sides would be e to the power u will be e to the power root of x square y square. This will be e to the power x square y square to the power half. This will be e to the power xy. They may want to ask you whether all these functions are the same or not. So, you know, you are just trying to see whether the different things are transformation of each other or not. And the easiest way to check that would be to find the MRS. So, anyways, this is the transformation. Once you have this transformation, just find out the MRS. The MRS is when you differentiate with respect to x, you will get 1 by x. When you differentiate with respect to y, you will get 1 by y, and this will give you y by x. So, you know, at any point of time, you have different functions to work with, and different functions will give you different MRS. There are various examples of utility functions. The most common utility function that would be given to you in exam would be a Cobb-Douglas utility function. A Cobb-Douglas utility function is also known as a well-defined utility function. Why is this called a well-defined utility function? Because it satisfies all the properties of the utility function. All the axioms are satisfied. 1. 2. It satisfies diminishing MRS. I will show you shortly how few of the indifference curves do not satisfy the property of diminishing MRS. But Cobb-Douglas is that well-defined utility function on which everything is satisfied. So Cobb-Douglas utility function is usually written in the form of x to the power a into y to the power b, where a and b are positive, values. And this a and b indicates the relative importance of the goods. So, question. This was asked in one of the entrance exam. If my utility function is x to the power 2 by 3, y to the power 1 by 3, which good is relatively more important? Because alpha is 2 by 3 and beta is 1 by 3, I will say that x is relatively more important. You can also check how these are the weights given to the function by taking log on both sides. If I take log of ux, I will get log of x to the power 2 by 3, y to the power 1 by 3. This would be, log mn. So this would be log m plus log n. And then, I'll bring this down. When I'm writing log, please assume this to be ln. I'm actually taking it to the base of exponent, okay? So this will be 2 by 3 ln x plus 1 by 3 ln y. So actually, good x is getting a weight of 2 by 3 and good y is getting a weightage of 1 by 3. So in that way, alphas and betas represent the weights that you assign to the goods. Let's take the example of how Cobb-Douglas function looks like. The Cobb-Douglas function, because I mentioned, is a perfectly well-defined function. It looks exactly like this. A usual utility function. That's your Cobb-Douglas function for you. Now, the other utility function, which you should know, are called perfect substitutes. Examples of perfect substitutes can be, let's say, tea and coffee. They are perfect substitutes for me. Example of perfect substitute can be from the daily routine that we know for now, COVID shield and Covaxin. Because one can take either of these two vaccines. So these two vaccines are perfect substitutes of each other. You take one Covishield or you take Covaxin, right? So they are perfect substitutes. A utility function of perfect substitute looks of this form: alpha x plus beta y. How do we represent this? They're represented by lines instead of the curves. Why? Very simple, right? Let's take u of xy to be 10. Let's say alpha is 1 and beta is also 1. I'm holding utility constant at 10. Then my function would be x plus y is equal to 10. How would you plot this function? This is a simple line. How do I plot this? When x is 1, y is 9. When x is 0, y is 10. When y is 0, x is 10. That's a line for me. If my utility increases to 12, I will have another line passing like this. So perfect substitutes basically are these downward sloping lines. And again, these alphas and betas are basically the rates at which you will substitute one good for other. The indifference curve will be linear. MRS, if you ask me how to find MRS will be differentiate the function with respect to x, differentiate the function with respect to y. With respect to x, it will be alpha. With respect to y, it will be beta. So my MRS will be alpha by beta. The third kind of indifference functions that you have are complements. Complements are the indifference functions that are to be used together. So, you know, an ideal example of complementary good would be pen and ink. But from a daily life, I can say for now that for today, for me, my complements would be mask and sanitizer. I want to always keep them together. So utility functions that represents goods that are consumed together are complement goods. How do we write the utility function? The utility function is written as this: min of alpha x comma beta y. Now, I would, these are L-shaped functions. I would like to go ahead and explain this a bit more. So let's say that my alpha is 1 and my beta is also 1. And let's say my utility function is min of alpha x comma beta y. This is min of x comma y because alpha and beta are 1. Okay. I want to keep my utility constant at 10. Right? Now, I'm going to take different cases and see how it becomes at most important. So, you know, let's say for now that my good x is left shoe and good y is right shoe. And I'm going to go ahead and plot my function now. So, supposedly, I tell you that I have one left shoe and I have five of right shoes. In that case, I will be only able to make one complete pair. So even if I have 5 right shoes, because I just had one left shoe, I just have one shoe pair completed, right? Similarly, let's say that I have 10 units of left shoe and 20 units of the right shoe. I will only get 10 pairs. Supposedly, I have 10 units of the left shoe and 10 units of the right shoe. I still get 10 pairs. Supposedly, I have 20 units of the left shoe, but I just have 10 units of the right shoe. I still get 10 pairs. So whether I had 10 of each or I had 20 of this but 10 of this, or I had 20 of the right shoe but only 10 of the left shoe, this point, this point, this point, all the 3 points will only compensate, will only give me 10 pairs, irrespective of whether I have more of the other shoe. So because they make exactly same number of pairs, all of them should give you the same utility. And that means they should lie on the same indifference curve. So I can join these points together and this will give me my indifference curve. This kink right here shows me equal number. If you keep on increasing one, but you don't increase the other, it gives you the same utility. Similarly, if you keep on increasing the other, but you don't increase this, it gives you the same utility as the kink point. So that is why these are these L-shaped curves. The utility that is given here at the kink, where the two are equal to each other, is the same that is given here, 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 or here, 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 here. So, therefore, whenever I will be solving them mathematically, whatever will be coming inside the min function, I would be just equating that. I would be just saying that, you know, my utility is defined wherever alpha x is equal to beta y. Because alpha and beta were 1 in my case, I will simply say my utility is defined wherever x is equal to y. Because when x is equal to y, that's this kink point. When I have 10 units of left shoe and 10 units of right shoe. And that would give me the same utility whether you give me 50 units of left and just 10 units of right, or 50 units of right and just 10 units of left. So numerically, whenever I'm going to solve this, I'm just going to equate whatever comes inside the min function. Very important. This says that your utility, so you know, this is a question that came in University of Hyderabad. I'm going to go ahead and assume that you know what budget line is. If not, then that is covered as part of the basic video. Please go through that once before trying to attempt this question. So, you know, I'm given a utility function, and the utility function is axy to the power half. My income is given to me as 656. The price is given to me as 8. And I'm asked to calculate the demand function. Now, to calculate the demand function, the aim is always to go ahead and maximize the utility for your given income. So your aim is always to maximize the utility subject to the budget constraint. Now, if I try and I do that, I'm just trying to say the following. I want to maximize u of xy subject to budget constraint, which is px into x plus py into y is equal to m. How do you maximize a function? You form a Lagrange out of it. So you are maximizing u of xy plus lambda m minus px into x plus minus py into y. You differentiate this with respect to x, you get del u by del x plus lambda minus px is 0. You differentiate the Lagrange with respect to y, you get del u by del y plus lambda minus py is equal to 0. This gives you del u by del x is equal to px into lambda. This gives you del u by del y is equal to py into lambda. I'm going to divide equation 1 by equation 2. If I do that, I'm going to get del u by del x upon del u by del y is equal to px into lambda by py into lambda, right? That is exactly what I'm going to get. This is going to be my MRSXY, because this is MUX by MUY, and this is going to be my PX by PY. So this is my equation at equilibrium, right? If I go back and I solve for it, I'm going to get MRSXY is equal to PX by PY. To find MRS, differentiate the given utility function with respect to x. So when I differentiate it with respect to x, I will get half into a into xy to the power minus half into y. If you find this part difficult, please do a transformation. So take logs. So supposedly your utility function is axy to the power half. And if you're not able to directly get this differentiation with respect to x, just take a log. So you know, log of u will be log axy to the power half, which will be half log of axy, which will be half log of a plus log of x plus log of y. And now just differentiate. So you know, if I have to find out with respect to, you know, if I have to find out with respect to x, it is going to be half into 1 by x. If I have to find out with respect to y, it will be half into 1 by y. So my MRS xy will be half into 1 by x by half into 1 by y, which will be y by x. This is one way of finding MRS. Otherwise, you know, this is your MUX. You can find your MUY also by differentiating this directly with respect to y. So it would be half into a xy to the power minus half into x. When you will divide MUX by MUY, this will get cancelled, this will get cancelled, this will get cancelled. You will be left with y by x. So either you directly differentiate if you're very clear with the product rules and partial differentiations. If not, then you take transformation and then differentiate. Now, once you have differentiated the function, you know your MRS xy is y by x. Y by x should be equal to px by py. Now, px is given to you as 8 and py is not given to you. So I don't know what my py is. Now I have reached this much, right? That y by x is equal to 8 by py. So I'm going to write this down somewhere. So y by x is equal to 8 by py. Now I'm going to put this in my budget line. My budget line was px into x plus py into y is equal to m. And income was given to me as 656. So I'm going to put here 656. Px is going to be 8 into x plus py is not given to me into y. Okay. Let's just solve it from here. This is my equilibrium condition. My equilibrium condition says that if I just cross multiply, y into py is equal to 8 into x. So instead of 8x, I'm going to replace it by ypy. So I'm going to get y into py plus y into py is equal to 656. Or I'm going to get 2ypy is equal to 656. Y into py will be 328 or y will be 328 by py. So this becomes your answer. So you see, even in University of Hyderabad, when the question is given, you do not directly get an answer for it. You have to solve. You have to know what your equilibrium condition is. MRS is equal to px by py. You have to know once you find your equilibrium condition, that has to be put back to the budget line. And once you put that back to the budget line, you get the answer. So the answer will be 328 by py. That is the demand function of y. What I would want you to do is I'm going to go ahead and give you an assignment on whatever we have done. You're going to solve that. And you're also going to try this question, and we're going to discuss this in the next class. So you're given income. This is very simple. You're given income, you're given price of food, you're given price of shelter, you're given quantity of shelter, quantity of food. Just give the budget line. So budget line will simply be price of food into quantity of food plus price of shelter into quantity of shelter is equal to income. So quantity of food is given as F. Quantity of shelter is given as S. This becomes 1. So the answer is PF into F plus this into this is equal to M. Because you don't have it in this form, let's solve it. So if I solve it for F, I will get F is equal to M minus QS by S divided by PF. Do we have this? No. Let's solve it for S. S will be M minus PF into F by QS. Do we have this? By S. This will be PS. And this will be PS. So F is equal to M by PF minus PS by PF into S This is for food. S is equal to M by PS minus PF by PS into food. If any of this is, if this is given to you, this is not given to you. If this is given to you, this is not given to you. The first one is also wrong. So the answer is none of them is correct. Okay. So I'll give you an assignment based on what we have done today. It would be posted, and please try and do that before the next class. Any doubts that we have, anything that we would want to clarify?